Hey guys, Michal Hucko here and welcome to another video in our Python for Beginners tutorial. In this video we're gonna talk about Python exceptions and how to handle them. In the previous video we covered nested loops and all the other fun stuff, so please check out the previous videos if you are not familiar with the topic. Let's dive right into the hands-on part of the Visual Studio Code. Now, what are exceptions? So let's start with a simple function where we want to divide two numbers. So def division, and we want to divide two numbers, a and b, and we're gonna go for result equals a divided by b, and after that we're gonna return the result, right? So what's the problem with this? So having a simple division like 4 and 2 cause nothing. We can run the definition of the function. Yeah, don't forget to run the Python 3 in the terminal before. So we run the definition of the function without any problem, press enter, and then the division will output 2. Amazing. Everything is working correctly, no problems. But the problems arise when we try to divide by 0, and this can sometimes happen. Now, when we try to divide 4 by 0, we get the 0 division error. And this will interrupt our program and can cause a lot of trouble in the production environment. Now, when I will talk about the production environment, I mean the environment where you cannot make fast adjustments. For example, you are developing a code and you want to try to sell it to somebody. You will sell the code, and after that the code is running in the production environment, so the customers are running the code. And when the error will occur in the production environment, it will break your whole code, your whole application, and the customers may get angry. Now, how we can solve this? How to solve exceptions or errors in the Python? Now, Python provides us the way to handle something which is called exceptions. So whenever an error occurs, the Python raises an exception. Now, and we can try to catch these exceptions. So literally in the Python we are catching exceptions. Now, how we can do that? Let's go into division and cover the code where we are making the division, because basically, as you can see, that's exactly, so previously the code was like this, right? And Python is saying us that in the line 2 there is a problem with the division. So in the line 2 we are dividing it. Yes, and then it's propagating to line 1 because it's saying, well, on the line 2 you have the definition of the division, and inside the definition on line 2 there is happening the exception. So like the Python is propagating the error up to the root cause of it. Now, how can we solve this? So let's just cover our division into try except syntax. So try except, and now everything what is in the try, Python will look for the exception defined in the except part. So right now we want to get the 0 division error, and we can name this error. Well, let's just put it like this, and I will explain later. So now, whenever a 0 division error happens within the try block, the exec block will do something. So then we will print to our user, please don't divide by 0, right? So now we again run the definition, press the enter, and when I run the function again, I can see that there is some error called unbound local error, local variable result. So what is happening right now? So let me explain to you. Python will first try to assign the result to a division of a/b, a divided by b. The problem is that this division is causing an error, so it's throwing an exception, and this cause that the result will be not assigned at all, right? There won't be any value because this is returning error. Now the error is caught by the except clause, and then it's printing out, please don't divide by 0. We have it here. And then on the line 6, as we can see, line 6, we are trying to return the result. But there was an error, and as I mentioned, the division didn't happen. So there is no result in result. So there is no value in result, right? So we cannot return a variable result, before assigning a value to it, right? And so this is exactly what is the Python saying to us. Now the right way to fix this is to put this return statement inside the try clause. So only if the try will result with assigning the result value, only in this case please return the result, and in other case please write down don't divide by 0. Okay, right, so this was a tricky one. So now when I run it, and when I run the division, as you can see, I will get please don't divide by 0, but when I run 4 and 2, I will get the 2. So try and except is a clause which help us to catch the exceptions, right? Which are reason because of Python errors. Now, but I was talking to what is this SE, right? So in order, well, sometimes we want to see the error message, right? Right now we didn't see the error message. We just don't know that we shouldn't divide by 0, right? But sometimes you want to print the error message which you saw previously without the except and without interrupting the code. So in this case, whenever Python raises an exception, the exception is catch inside this except clause, and when you put here this SE, the Python will assign the value of the output of the exception into the variable e, and now we can print exception was and the e, right? So with this SE, you can even skip it, and you don't need to use it there, but it's good practice to catch the exception and assign it to a variable, because that's quite a common practice in Python programming. And after assigning it to variable, we can print it to the end user. So again, run the definition, run it, and you can see please don't divide by 0. Exception was division by 0. So division by 0 is the exception. Right, now we have the understanding of the exceptions. But besides catching one, because you always need to specify the type of the exception you want to catch. Right, I will show you how to catch any exception, but for example, imagine you want to catch another exception. I will show you example. So let's imagine you want to run the division with A and B. Somebody accidentally ran your division code with A and B strings. Right, and what will happen in this case? We got an exception called type error, unsupported operand type division for string and string on the line 3. The line is here, and that's the division, and division is not supported for 2 strings. That's basically the thing what is Python saying to us. In many cases you will encounter exceptions. The first thing to do is read correctly the exception and look for the root cause of the exception. Don't just be like sad, like it's not working, and don't give up. Just read the exception carefully. Most of the time Python is trying to say you the right way how to fix your problems, and it's exactly in this case also. So right now we can catch another exception by specifying another except clause after that, catching the type error, adding it to e. Yeah, now I can reuse the e, because as you can see the variable is only usable in the scope, and the scope is defined by the indentation, and because this is on the same place, the e in this exception is not the same e as in this exception catch or the except. So now I can say please provide only numbers, print exception was e. Again, we will run the definition. Yeah, I have here a syntax error, so please delete the sign which was here, because in this case it's a wrong syntax, and Python is just saying I have wrong syntax. Run the Python interpreter, execute the definition of the function, and now you can run it. As you can see, please provide only numbers, exception was unsupported operand, blah blah blah. Simple. Now let's go to another examples which I created for you in this try except file. So this is the exception which I was talking about right now. Let's go deeper. Imagine having these 3 functions. So first is the division, right? Second is the addition, and then I have a function which is called the calculator, and this is a very special function. It took 2 arguments, first number, second number, and a function. So right now in this example I'm passing a function as a parameter to a function, right? So now we can then run the function which is being sent to the function as a parameter with two other parameters from the function. Feel free to pause the video and check out the syntax. Now, and how do we call it? We can call calculator 10 and 5 division. So in this case, when you look into calculator function, the function variable will be replaced with division and will be called with x and y. And the division is defined above, right? So when I run all of these definitions, press enter, and when I run the code for the division, I got 2. When I want to run the addition, I just change the division for addition. And this is a simple way how I can pass the function to a function as a parameter. But what I wanted to show you is that in the division, I have a traditional exception, right? So a traditional try except statement. And as you can see, after catching the exception in this part, I'm raising the exception to another level. What does it mean? So imagine it's not here. So I will delete this guy and I will add it here like this, right? And I will also delete this try catch from here just to show you the example what I want to show you. So imagine it's just like this, and now I will run the division with the 0. And now we can, oh, sorry, I didn't run the definitions. And now when I run the division by 0, you can see that first, read the trace. This is called a trace. So 0 division error, division by 0 at line 2. Now the lines are starting from here because when you select it, the line numbering will start for your selection, not for the file. So it's saying the division, so let me I will just rewrite it to another file so you can see it clearly. So, and now I'm gonna run the Python file in terminal. But for this case, I need to quit the Python interpreter. Yeah, and as you can see, so division by 0. So there is an error in the hands-on py, which is the name of the file which I'm running, on line 2. So there was the error, and then the error is propagated to the hands-on part line 14. And what is line 14? That's this return statement. So as you can see, because here I am calling the division, which is replaced for the variable which I'm sending there, the error will be traversed from division up to calculator, and then it will go up to line 16 here when the actual call happened. And this way, using this trace, you can find out the place where the error happened. Now, and if you look in here, what I did was that I changed the division function to this. So let's adjust the division function. So I'm trying to catch an error, any kind of exception. So any kind of exception, this is a general exception clause. So any exception happen, after getting the error, I'm saying error in addition, and I'm raising the exception to another level. So this exception will be sent to the place where the division is called. And because we see the trace is saying us that here in this function the error will appear, right? So if I run it right now, you will see that still I have the 0 division, but the error in addition division by 0 was printed because I got the exception. And as you can see, Python is saying us right now, yes, so there was an error on line 3, that's here because the trace is in memory, was then returned on line 6, that's was then appeared on line 6, that's here because we raised the error. then it appeared on line 18, that's here, and then it appeared on line 20, right? So in order to catch the error in this part, we need to adjust the calculator function to a function which I specified right here. Sorry. And as you can see, after calling the function, I'm catching any exception. And then I'm saying, please fix this. I'm also adding a return value in case of exceptions. So exceptions can also return value. But the thing which I wanted to show you is that you can raise an exception from the function call within the function. I know this can be quite complicated, but if you run this code, you will see that no exception is presented anymore. Everything was catched successfully and every output was printed. Please pause the video and take your time to go through this code. It's quite essential to see how the function calling can be chained and the exceptions can be propagated through the function, right? So going that to try exceptions, to try except file, you can see also there are some other interesting examples. For example, the Python provides us a keyword which is called, or keyword connected with the exceptions, which is called finally. And let's look at this example. We have this example called example finally, and I'm catching exception within this block, and within this block I'm just printing A, but I'm raising an exception, right? What does it mean? When the Python interpreter will go to this line, it will print the A, and then it will go to this line, it will raise an exception, which will be caught in this except block, but the return won't be run, right? So we will not return A in this case, but the B will be printed, and then the B will be returned, right? And because we know how function works, after things being returned, nothing else from the function will happen. But because we are using finally, what finally does is that whenever a try except block is presented, the body of the finally will happen anyway, even when there is a return in the function. So when I run this code, again, don't forget to open the Python interpreter. So when I run this code, press enter, and I execute example finally, I will see the A because the print A is here. After that, I will raise an exception, fine. Then I will print B because the exception except blocked is being executed. Then I will return B, but because there is a finally, I will print C. Now let me show you a difference. If I delete this finally and put it only like this, no print C will happen, right? Why? Because whenever function returns something, the rest of the body won't be executed. Now you can ask me, well, Michal, but what is this good for? And I to be honest, I can say there have been just few occasions when I use the finally statement in my code. So feel free just to keep this information as a small bonus part of the exceptions. You maybe will not use it, but whenever you will encounter it, you will recall the Michal Hucko, who was telling you how this finally part works. Okay guys, thank you very much for watching this exception part, and I see you guys in the next video.